All right, Algebra 2. Section 4.6 is kind of the gateway into some of the harder stuff we're going to be doing at the end here of Chapter 4. In 4.5, we started solving quadratic equations just by one method, and that was factoring. And that seemed like it was well and good, and you guys are probably wondering, why would we ever need to learn a second method? Well, the answer is, and this isn't always obvious to you guys here, factoring, as fun as it was, doesn't always work. And sometimes even when it does work, it's really, really difficult, especially when you have a lot of choices for how to split up your A and your C terms. So the two other methods we're going to learn here, this one called completing the square, and in 4.7 we'll learn about the quadratic formula, have two things going for them. Number one, they always work. Even though this one right here, completing the square, there are certain cases you'd really prefer not to use it, but we'll get to that later. The second thing they have going for them, they're a little bit more direct than factoring. There's one set of steps we always follow. And so, even though sometimes you can get messy answers this way, there's less hunting and pecking, guessing and checking, things like that. So, we're going to dive into it. This is a long section here, guys, so I'm going to break this up into at least 2 videos, if not 3. And the first section we're working on right here says that we're going to solve these equations here using inverse operations. Now, this is kind of a prerequisite step to what we're eventually going to be doing called completing the square. But in these first 3 examples I have for you, we're not actually completing the square just yet. Now, inverse operations, you guys probably, if you don't know the name, trust me, you know what you're doing. You guys learned, don't write this down, back in Algebra 1, for example, that if you had a simple equation like x minus 8 is equal to 13, okay, you were taught, find the x, find what's being done to it, and undo that. You know, in this case, they're subtracting 8 from x. So how do we undo subtraction of 8? We add 8 on both sides, because addition is the inverse operation of subtraction. So those cancel, and we end up with our answer here, x equals 21. That wasn't hard. Or if they gave you something like x over 7 is equal to negative 5, okay? Your Algebra 1 teacher said, okay, find your x. Well, there it is. What's being done to it? It's being divided by 7. And how do we undo division? The inverse operation of division is multiplication. So we'd multiply both sides by 7 and get x equals negative 35. That is how you solve a simple linear equation with inverse operations. Whatever's being done to x, you undo it with its inverse operation, and that helps you get the variable by itself, and that's our goal here. Now, what we're dealing with in this first example here is a quadratic equation. 3x squared minus 75 equals 0 is quadratic because it contains an x squared. And that's the hallmark of any quadratic equation. If it doesn't have anything higher than 2 for the exponent, if that's as high as it gets, it's quadratic. However, I do want to point out, earlier in this chapter, you guys saw equations that looked maybe like this. 3x squared plus 11x minus 75 equals 0. Now, this is also a quadratic equation because of the x squared, but this is what we would call a more difficult quadratic equation, and this one is what we would call a simple quadratic equation. And what's the difference? This term right here. A more difficult quadratic equation has both an x squared and what we call a linear x term, whereas the one we're dealing with here has a quadratic term, x squared, but it has no linear term. So the key here is that this equation here has only one x, whereas this one right here has 2 x's. This one and this one right here, that becomes a lot harder. Okay. So that is something we will deal with later on. Here we go. How do you solve this using inverse operations? We've got 3x squared minus 75 is equal to 0. Our job here, guys, just like it was in Algebra 1, is to figure out what is being done to x and undo things in the proper order. Now, we are all well familiar with the concept of PEMDAS, right? Please excuse my dear Aunt Sally, the order of operations in which things get done. So let's take a look. Here's our variable here, and the first thing in this list that is happening, well, there's no parentheses, but we do have an exponent. The first thing happening here, guys, is that x is being squared. I'm going to make a little list off on the side right here. Okay, so there's exponents. After that, do we have any multiplication or division? Yeah, right here, the x squared is being multiplied by 3. That takes care of that. And then, do we have any addition or subtraction? Yeah, there's a minus 75 that is actually the last thing that's happening to x. So you have to be able to identify what's being done to my variable and what order is it being done in. And now, everybody, whatever order these operations were being done in, we are now trying to reverse that process. We're trying to get x by itself. So we actually go back up the ladder here like this, and we start off getting rid of this first. The last thing being done is the first thing that we undo when we're solving with inverse operations. So we have to get rid of the subtraction first. And how do you get rid of minus 75? You add 75 on both the left and the right. So those terms cancel out, leaving us with a 3x squared is equal to a 75. Okay, and we got rid of the subtraction. Let's keep going up the list here, guys. The next thing we need to get rid of is the multiplication by 3. So to undo multiplication by 3, we divide both sides by 3. Those 3's cancel, and we now have x squared is equal to, and 75 divided by 3 is 25, and we just took care of the multiplication. And the last thing that remains that we have to get rid of is the square. X is being squared, and we need to undo that with, well, the inverse operation of a square. As soon as you say it out loud, it makes a lot of sense. How to undo a square? A square root. And we'll do that on the left, and we'll do it on the right as well. The square and the square root cancel each other out, and we just get x equals, and here's where things get just a little bit interesting. Every one of you just looked at this as soon as I wrote it and said, oh, duh, the square root of 25 is 5. And you know what? You're right. 5 is a solution to this equation, which I could verify by plugging it in right here for x. You would take 5 squared, which is 25, multiply that by 3, which is 75, and then subtract 75 to get 0. So 5 is a solution. However, that is only one of the solutions, and there is another one. There is another number out there, guys, you know it, that you can multiply by itself and get it to equal positive 25. And the answer to that is negative 5. So you also then would have to consider x equals negative 5 as a solution, because if we think about it, negative 5 times itself, that's negative 5 times negative 5, that equals positive 25 also. So the idea we have to get used to here at the end of chapter 4, everybody, is this, that every number has 2 square roots, one of which is positive and is usually pretty obvious, but the other of which is negative. Now, you would be perfectly fine if you wrote your answer this way, x equals 5 or x equals negative 5, but the cool kids are going to save a little bit of time right here, and they're going to use this symbol in front of their 5, plus or minus. So x is equal to plus or minus 5 means that there's actually 2 solutions right here, and either one of them will work and give you a true statement when you plug it back into the original equation. So that's a little mental hurdle we're going to have to get over here, guys. The square root of 25 isn't just 5, it's actually plus or minus 5. Okay. And that's our first equation that we're solving using the concept of inverse operations because there's only one x in the original equation. Let's take a look at a second example here. This one is x plus 4 quantity squared is equal to 40. So if we think now, everybody, about what is being done to x and in what order, let's go through the list of, please excuse my dear Aunt Sally. The P stands for parentheses, and what that really means is do what's inside the parentheses first. Well, what operation do we see inside the parentheses? The addition of 4 is actually the first thing being done to x. Then, once you've taken whatever x is and added 4 to it, the next thing you have to do is square all of that. And those are the only 2 things that are being done to your variable on the left-hand side. So those are the 2 things that we have to undo, and we have to undo them in the opposite order in which they were done. So first, we get rid of the square. Okay, the last thing happening on the left side is a square, so we need to undo that with a square root on both sides. Now the square and the square root on the left cancel each other out, so we get x plus 4 equals, and right now there's a big thud, sad trombone, as Mr. Murphy would say, wah, wah, going through your head right here. 40 is not a perfect square. So this is one of the problems, the first one we're seeing here today, where you're going to have to know how to simplify radicals in order to get these problems correct. Now, I've recorded and posted a separate video on how to simplify radicals, so you might want to look that one up if you need a little bit more help than this. But what I'm going to try to do is split up that 40 into the product of two different numbers, one of which needs to be a perfect square. And the way I explained in that video you should approach this, take this number, 40, cut it in half. Half of 40 is 20. And it would be awesome if 20 was a perfect square, but it's not. You look at 20 in that table, and then you start thinking about perfect squares that are close to 20, but smaller than that. We'd start with 16. 16 does not go evenly into 40. The next perfect square lower than 16 is 9. 9 doesn't go into 40. The next one lower than 9 is 4, and 4 does work. So we can split that 40 up into 4 times 10. Then we break it up now into the square root of 4 times the square root of 10, and the square root of 4 can be evaluated, and we end up with 2. You know what, I'm going to move all this down right here. We end up then with a 2 multiplied by the square root of 10. You can evaluate the root 4 to get this 2 here, but you can't simplify the square root of 10. It's an ugly, irrational number, and we just have to deal with it. Now, the only thing here, let's go back to the previous example we just did. When we got right here, guys, the square root of 25 wasn't just 5, it was also negative 5. Every number has two square roots, one positive and one negative. Well, that same thing happens here to a number like 40. Both positive and negative 2 root 10 will work, so you need to put your plus or minus in front of that. Okay, so we got rid of the square, everybody. Now we just need to get rid of the plus 4, which we will do by just subtracting 4 on both sides. Now the left side is easy. Those terms just cancel, and we get x equals. And again, I want to show you guys the way that almost every math author and every good math student in the world does this. What we usually do, we'll put this number, that number there, out in front, negative 4, and follow that now with a plus or minus 2 times the square root of 10. And I have good news for you guys. These numbers right here cannot be combined. For example, this is kind of like negative 4. What if I had plus 2, and instead of a root 10, what if I just put an x there? Every one of you would tell me, okay, you can't put those two together because they're not like terms. This term contains an x, this one doesn't, and you would be right. Well, the exact same thing happens right here. This term also contains a factor, not an x, it's a root 10. But since this term does not contain the same factor of root 10, you can't put them together, guys. You can't combine them. And good news for you, this is actually the final answer to example B here. All right, this format of an irrational answer, guys, is one we're going to get used to here at the end of chapter 4. That's why it's really important that you guys are checking your answers to all of your homework problems, so you get used to the idea that, oh, okay, I can have an answer that looks something like x equals negative 4 plus or minus 2 root 10. It's not pretty, but that's what it is. Okay, so that was example B. And example C, last one I want to do with you here in this short video here, guys, short-ish, I think is maybe actually a little bit easier than example B, but we'll see where we're at. All right, guys, find your variable. Whoop, there it is. And now start thinking about what's being done to it. If I think about PEMDAS, the P means parentheses, and it really means look inside the parentheses. That's what's being done here first. And inside the parentheses, x is being multiplied by 2, and then they're adding 7 to that. So all of that takes care of the parentheses. There's the P in PEMDAS. Now, once you're done with everything in the parentheses, keep thinking about that acronym right there. The E in PEMDAS stands for exponents, and the square is the next thing that's going to happen. And then, after the 2x plus 7 has been squared, then the m says that we multiply here by negative 4. And I think that's it, guys. I think those are the 4 things that are being done. So therefore, those are the 4 things that we need to undo in the opposite order. So we actually start right here. How do we undo multiplication by negative 4? We divide by negative 4 on both the left and the right. So those negative 4's cancel, leaving us with 2x plus 7. Quantity squared is equal to, and negative 36 divided by negative 4, positive 9. So we took care of that. The next thing we need to get rid of, the last thing happening now on the left side of this equation, is the square. And how do we undo a square? Square root of the left, square root of the right. So the square and the square root cancel each other out, and we get 2x plus 7 is equal to, and let's not make this easy mistake, yes, the square root of 9 is positive 3, but it is also negative 3. So we'll put a plus or minus in front of that, knowing that that's actually 2 different numbers. And now this gets interesting here, guys. All right, we took care of the square. Now we have to take care of the plus 7, which we will do by subtracting 7 from both sides, but I want to show you guys how to handle that right side. The plus 7 minus 7 cancel each other out, and we get 2x equals. And now, everybody, what we need to do is remember that that plus or minus 3 is actually 2 different numbers. So we really have 2 different equations here. Let's focus on the positive first. What is positive 3 minus 7? That is going to get you negative 4. But wait, there's more. There's a second part to this as well. Let me rewrite that 2x equals, and now you guys, let's focus on the negative 3 right here. What is negative 3 minus 7? That is going to give you negative 10. So you have to consider both the positive case of the 3 and the negative case of the 3. And now we get rid of that multiplication by 2 by simply dividing both sides by 2, and I need to do that in both of my equations here. So those 2's cancel, those 2's cancel, and we end up with x equals negative 4 divided by 2 is negative 2, or here we get x is equal to negative 10 divided by 2 is negative 5. So we ended up with 2 different solutions here for this quadratic equation. Both of them will give you true statements if you plug it back in to the original equation. I'm going to ask you guys to trust me on that one. All right, everybody. So that's 3 examples that illustrate the concept of how to use inverse operations here to solve a quadratic equation. I'm going to stop this video right now and then make a new one now, moving into the actual concept here of completing the square, which we'll get to here pretty soon.